All right, this is the last of our series of videos on time value of money concepts. This is part 5, in which we're going to talk about the other type of annuity problems, which are annuities due. We talked in the last video, the last 2 videos, on annuities that have 4 factors, either the present value or the future value, the interest, the number of periods, and the amount of payments or receipts, which are called rents. Now, if the rents occur at the beginning of each period, then we're going to call this an annuity due. Okay? It has this extra interest from the first period. Okay, so it has one more interest section than an ordinary annuity would. Okay, so if we need the future value, like in this timeline we see here, where we need the future value of the rents, we can take table 2 factor, which is the future value of an ordinary annuity, and multiply by 1 plus the interest rate, and that will give us the factor. You do not have a table in your book for the future value of an annuity due. We do have a table for the present value of an annuity due. So this just is a picture that shows you if it's an ordinary annuity, it's going to start at the end of the year or the end of the period. It's annuity due, it starts at the beginning. So you have this extra interest period that you're going to get. Here is an example of future value of an annuity due. Mr. Goodwrench deposits $2,500 today in a savings account that earns 9% interest. Plans to deposit $2,500 every year for a total of 30 years. How much cash will he accumulate in his retirement savings account when he retires in 30 years? Okay, the first deposit is today, and rents are at the beginning of each period. So this is an annuity due. Okay, so there's not a specific table in your text for the future value of an annuity due. So we're going to use table 2, which is for an ordinary annuity, and then we're going to modify it. We have to multiply it by 1 plus the interest rate. So here is where we solve this, okay? And the future value of 1, okay, for 30 periods, okay, of an ordinary annuity, that is table 2, okay? If we look up table 2 for the 9% interest and 30 years, we get 136.30754. That comes straight from that table too, okay, for 9% in 30 years. Then we're going to multiply that factor times the 1 plus the interest, which is 9%, which is 0.09. So 1 plus the 0.09 is 1.09. So I'm going to take the 136 factor from table 2, going to multiply it by 1.09. That gives me 148.57522. That is now the factor that I'm going to use. So my formula is FV, that's what I want, equals rents times table 2 modified. So the table 2 modified is 148.57, and I'm going to multiply that times the rents, which is $2,500 a year. Okay, and so that equals $371,438 that he'll have at the end of 30 years. Okay, Here's another example. Bayou Inc. will deposit $20,000 in a 12% fund at the beginning of each year for 8 years, beginning January 1st of year 1. What amount will be in the fund at the end of year 8? So again, we're asking for the future value. So it's future value equals R times table 2 modified. Okay? If the 20,000 each came at the end of each period, then we would just use table 2. That'd be it. We wouldn't have to modify it because that would be an ordinary annuity. But since these 20,000s are coming at the beginning of the period, we're going to get the factor out of table 2 and then we're going to have to modify it. Okay? So we're going to have to get the table 2 value for 8 years and 12%. We'll get that factor. Then we're going to multiply it times 1.12. That's 1 plus 0.12 of the interest. Okay, so here we're looking in the table 2, and we're looking down the 12% across the 8 years. We get 12.29969. We're going to have to take that factor and then multiply it times 1 plus the interest. The interest is 0.12, so 1 plus 0.12 is 1.12 times the 12.29969. So that gives us a factor of 13.775652. That's the factor we're going to use in our formula. And of course, our formula is the future value equals the R times table 2 modified. Okay, this is our table 2 modified factor. Here's our R, which is 20,000. So 20,000 times the 13.77 is our future value of 275,513. All right, so now we're going to talk about the present value of an annuity due. So again, just like other annuities, we either have or need the present value or we have or need the future value. So we just got done talking about the future value. Now we're going to talk about, well, what if we have or need the present value? Okay, so and we're still talking about an annuity due, meaning the amounts, the rents are happening at the beginning of each period. We do have a table for present value of an annuity due. It's table 5. Okay, the formula is going to be we need or have the present value equals R times table 5. Okay, so here is an example where we have 100,000 rents at the start of each period. Okay, and the period is 20 years, and we have an I of an unknown amount, but we want to know the present value. Okay, so here's Jamie. She wins $2 million in the lottery. We already worked this problem before, but now she's going to be paid $100,000 at the beginning of each year before we looked at the end of each year. Okay, for the next 20 years. How much has she actually won? In other words, what's the present value? Okay, interest rate of 8%. So she's getting 100,000 today, and then 100,000 the beginning of each year, and for 20 years. So she gets the $2 million that way. But what is that worth today? Okay, so we need the PV of an annuity due. So we're going to use table 5. PV equals R times table 5. Okay, so here's table 5. We have 8%. We're going to go down to 20 years. Okay, and that's 10.60360. We take our R, which is 100,000 a year, times the factor from the table 5, and that gives us the present value, 1,060,360. If you'll recall, the present value of when she had an annuity due was 980 some thousand. Okay, and so this is quite significantly more just by moving the first payment to now, to a year early.